Hello everyone and welcome back. So let's take a look at this and see what we have. So if we hit play, we get our sphere going and the smoke is moving. Great. So we have, we're emitting density and temperature, and for the, I want to explain the new combustion model quickly and what we need for it. So we don't need temperature, we need to inject flame into flame. And I can copy temperature, density, whatever, as long as there is an input coming. That's all I need. And let's make sure we display the temperature, or sorry, the flame. And it is working, so let's hit play. And let's increase the emission scale. So that's our flame, and we also have smoke, our density. Okay, cool. So as always, we have few controls. We can either we can take that data, which is called flame, and emit smoke from it. And this is the range of or how dense that smoke is going to be. This is not expansion. Okay, this value is not going to emit more smoke. It's going to change the density of the smoke that's going to be emitted. Okay, so right now it's going to use the values of the flame where they are between 0.2 and 0.5. So super hot flame is not going to emit, it's excluded from that. And super weak flame is not going to emit as well. Only things that are in this range. So if we hit play, we should see more density or denser smoke coming off of this. Let's set it to 10 and let's make sure we're seeing that smoke. Okay. Yeah, we can see here around it the smoke is more visible. So that's it. This is not going to emit more smoke, just to be clear. It's going to change the density. The next thing, we can also add temperature. So flame is not responsible for causing the smoke to rise. It's going to emit temperature. Okay, and this is sorry, by default it doesn't emit temperature. This is where we can have it do that. And if the flame is going to emit temperature, then it's going to cause the smoke to go up. And here I'm multiplying the amount. Okay, and I'm going to use add because the poll method it wasn't working for me, so I'm gonna stick to add. And let's say, okay, the range of the flame is anywhere from 0 to 1, doesn't matter. As long as there is a flame, I want to emit smoke. And now we're gonna see that the smoke is gonna go up, or basically behave, because now we have temperature. Okay, and because it's moving also, that flame is still emitting smoke whenever it's present. So let me go back. So here we have a temperature of ambient temperature of 0. I'm going to change this to 300 and let's set this to 10,000. Yeah, and it's too fast. Okay, let's set this to 2,000. That's too much upward movement. Let's set this to 600. Okay, I'm going to leave it at that. And I'm going to go back to the flame and lower this to 10. Cool. So we're emitting smoke and it's rising. And see, we're only seeing the flame now. I don't care too much about the flame. As long as it's coming in, we're good. I care about the temperature. That's where my information is going to be. So these two, I'm going to change the temperature. And let's lower this to 400. Actually, let's set it to 500 and lower the temperature multiplier. Cool. So that's it. That's it. I have these 3 tabs, and then this lifespan is basically how long that flame lives. By default, it's gonna have a value of 2, and it just means that it's going to take 48 frames for a flame value of 1 to completely dissipate. And the longer this, the higher the value, the longer the flame is going to be. And I have some wedges that I'm going to show. Now this expansion is what injects divergence. Divergence is what causes the smoke to expand. And this is very useful for explosions and things like that. And here we have a multiplier that's going to say, okay, expand the smoke, or take the flame field and copy it into the divergence field, which will then causes the smoke to expand. And right now I'm using 100% of that flame field. And you see now it's just going crazy. And 10 is too high, so we'll go with 2. And maybe we'll use only the portion where the flame is super hot. Let's try this. And that area now is expanding a tiny bit, and then with the temperature and everything. Okay, that's it. That's all there is for the new spars. I mean, in a nutshell, these are the major changes. Now we have these nodes as well that we can tweak. And I just want to have bigger swirls. And again, it's very fast because, you know, we're only simming there, so it's going to be very efficient. I'm going to go back to the source and add a trail node here and compute the velocity for the sphere. Let's see. And let's change it to polygons. Yeah, so we have temperature. I'm going to use a time blend node. And let's go back up. I'm going to increase the sub-steps to make sure that I don't get those gaps in the source. So 2 and 3, and then 5. Yeah, we're getting better emission. Less gaps, but we still need to increase it. And we can, obviously, because we have more sub-steps, the sim is evaluating twice between the frame, or 3 times between each frame, and that gives it more time to, you know, inject more temperature or more divergence. It's just the sim evolves more between a frame to frame. And the last thing is we can increase the resolution, obviously. And hit play. Now, one thing that was there all the time in the previous workflow was the gas resize field. That is no longer needed. Actually, you cannot use it. You have to let the sim decide where how it resizes the field, and sometimes each field is gets resized individually. You know, if you only have temperature in one area but you still have density everywhere, the sim is going to shrink that temperature based on its locality. Like where you only have temperature, it's going to sim that. Everything else is going to store only density. So it's very, very efficient, and you no longer need or can have the gas resize field, which we can do adaptively because side effects has to do that internally inside the sim. And we're going to take a look at some wedges just to explain a bit some of these concepts a bit more. But that's it. We're going to dive into the Houdini stuff in the next videos. Thank you guys for watching, and see you in a bit.